Okay, so for our next example, uh, we have the integral of sine squared x cosine squared x dx. Now, if you notice, the technique that we used in the past, in the previous examples, assumed that we had at least one odd power of sine or cosine. Here we have none, so we're going to have to employ a different technique for this. This is another one of those facts that I mentioned earlier on, you just kind of need to know. So we have, as identities, we have the cosine squared x is equal to 1 plus cosine 2x over 2, and sine squared x equals 1 minus cosine of 2x over 2. I know that, as I said earlier, I know you're probably expecting the second one. There must be a sign. There's something about the symmetry of that it seems if the cosine squared the rule has a cosine 2x in it, somehow the sine squared x should have a sine 2x, but it doesn't work that way. So here's what we're going to do. We're going to use these identities to rewrite sine squared and cosine squared. So this is going to be, let's rewrite this as, this is going to be the integral of 1 plus cosine, sorry, 1 minus cosine 2x over 2 times 1 plus cosine 2x over 2, like that. And now we're going to multiply everything out. So for one thing, we've got 2's in the denominators, so this is going to be 1/4, and I'm going to stop writing the denominator because I just have 2 times 2, so I'll just multiply whatever the result is by 1/4. Now what I'm doing is I'm just multiplying the terms on top. I have 1 minus cosine 2x plus cosine 2x minus cosine squared of 2x dx. Good. So these terms, of course, are just going to cancel each other out, so I'm just going to be left with 1/4, 1 minus cosine squared. I can, in fact, write that here, so this is going to be 1/4 times the integral of 1 minus cosine squared 2x dx. All right, now it might seem like the thing to do would be to use the fact that 1 minus cosine squared is equal to sine squared, but remember that's not going to be very helpful because if I convert this 1 minus cosine squared into sine squared, then I'm still going to be left with just the integral of sine squared. And since we don't have an odd power, we're not going to be able to use one of the other techniques. So we really have to forge ahead with this one. Well, the thing to recognize here is that I can use these formulas here on cosine squared of 2x as well as, for that matter, on sine squared of 2x, because when I rewrite it, whatever appears in the x position here just ends up in the x position here. So I'll show you how that works. This is going to be 1/4 times the integral of 1 minus, if I have cosine squared of 2x, I've got 1 plus cosine of 2 times 2x. That's what I mean when I say that whatever is in the x position in this identity has to go in the x position there. So it's going to be that over 2. So, so what we have here is this is equal to 1/4 times the integral of 1 minus, it's going to be 1/2, and then minus 1/2 cosine of 4x dx. So let's see, so this is going to be 1/4 times the integral of 1/2 minus 1/2 cosine of 4x. Now I think we're about ready to integrate. This is going to be 1/4. Integral of 1/2 is just 1/2 x, and 1/2 times the antiderivative of cosine of 4x is going to be 1/2 times 1/4 sine of 4x. And then we can just simplify. This becomes 1/8 x minus, of 1/4 times 1/2 times 1/4. That comes out to 1 over 32 sine of 4x. And of course, the hardest part of the problem is the plus c. And there we go. That is the integral of sine squared x cosine squared x.